Hello everyone, section 7-1, factors and the greatest common factors, part 2 for Algebra 1 students. In the first part, you studied two skills. Number 1, how to write the prime factorization of two numbers using two methods, the factor tree and the ladder diagram. Skill number 2, how to find the GCF, the greatest common factor of two numbers. In this part, you're gonna learn two skills. The first one, how to find the GCF of two monomials and a real life application. Find the GCF of each pair of monomials. The first pair, 8x squared and 7y to the power 3. Step number 1, you copy the first monomial 8x squared in the first line and you factor this monomial completely. This monomial is made up of two parts, the numerical part or the coefficient 8 and the variable part x to the power 2. When you factor the coefficient 8, you do the prime factorization, you take this 8 outside, you do the factor tree or the ladder diagram. Anyways, the prime factoring of 8 is 2 times 2 times 2. X squared is a repeated multiplication, it's x times x 2 times. Similarly, you take 7y to the power 3. 7, the numerical part, is already a prime number, so no need to factor 7. You copy the 7. Y to the power 3 can be factored y times y times y. To get the GCF of these two monomials, you need to circle any pair of common factors of these two monomials. If you look at the numbers, the coefficients, you will find nothing in common. Also, when you look at the variables x and y, they are different, nothing in common. So actually nothing in common except 1, because simply you can multiply the monomial 8x squared times 1. Everything can be multiplied by 1 because 1 is multiplicative identity. Similarly, 7y cubed is multiplied by 1. Now I have one pair of common factors. This pair, 1 and 1. I'm going to take one factor of them and the GCF of these two monomials is going to be 1. Another example. 18k squared. I'm going to take 18k squared and factor this monomial completely. If you take this 18 outside and you use the factor tree or the ladder diagram in order to factor the 18 prime factorization, remember in the factor tree you need to factor this 18 into the product of two numbers. One of them at least is a prime number, and since 18 is even number, you have to start with 2. You have to think about 2. 2 times what gives us 18? 2 times 9. We circle the prime numbers only, so we're not going to circle 9 because 9 is not a prime number. But we can factor this 9 into 3 times 3, and both are prime numbers. The prime factorization of 18 is the product of all those prime numbers, 2 times 3 times 3. 2 times 3 times 3. K squared can be extracted into k times k, or you can simply leave it like that, and I will teach you how to get the GCF of the variables later. Take 27k to the power 3. The prime factoring of 27 is 3 times 3 times 3 times k to the power 3. We're going to copy k to the power 3. To get the GCF of these two monomials, I'm going to circle any pair of common factors I find between the first one and the second one. 2 and 3, they are not common. I find 3 and 3 one pair of common factors. These 3 and these 3 are also common factors. So to get the GCF among the two coefficients, I'm going to take 1/3 of this pair times 1/3 of that pair times the variable with the least power. The variable with the least power is k to the power 2. Let's simplify our answer. 3 times 3 is 9, k to the power 2. The greatest common divisor of 18, k squared, and 27, k cubed, is equal to 9k squared. Now guys, you may pause the video and check your understanding. Take your time. Yes, it's true. The GCF of 16a to the power 6 and 14ab, if you take the first one and you factor completely, the second one and you factor completely, you will find the GCF of these two monomials going to be 2a. Second part, the GCF of 8x and 7v squared is exactly 1. The word problem. John is creating a website that offers greeting cards. He has 24 special occasion designs and 42 birthday designs, so two different sets of designs. The cards will be displayed with the same number of designs in each row. This is a condition. The two designs will not appear in the same row. This is another condition. How many rows? This is our job. How many rows will there be if John puts the greatest possible number of designs in each row? This is the key word of this problem, the greatest possible number. So guys, technically we're looking for the greatest common factor of two numbers. The first set of designs, the 24 special occasion designs and the 42 birthday designs. After you find the GCF, it leads us to find the total number of rows in this website. Let's get started. First of all, we need to find the prime factoring of 24. If you take the 24 outside and you think about the prime factoring of 24, either using the factor tree or the ladder diagram, you will find 24 prime factoring is 2 times 2 times 2 times 3. You can double check by multiplying all those prime factors. 2 times 2 times 2 is 8. 8 times 3 is 24, correct? The prime factoring of 42 is 2 times 3 times 7. And if you notice, guys, I'm trying to do what? I'm trying to line up the common factors. If you look at this pair, you will find this pair is in common, and these two 3's are in common. The GCF of 24 and 42 is simply the product of all common factors. From this pair we have 2 times, from that pair we have 3. The GCF is the product of 2 times 3 equals 6. So the GCF of these two numbers equals 6. It means in this website, each row has to be 6 designs. 6 designs in each row. Now, let's find the possible number of rows on this website. To find the total number of rows in this website, you need to get how many rows for the first design and how many rows for the second design. To get that, you need to divide the number of designs of the first design, 24, divided by the number of designs in each row, plus 42 divided by 6 simplifies. 24 divided by 6 is 4. 42 divided by 6 is 7. is equal to 11. So there are 11 rows of equal size groups of designs, and each group consists of 6 designs, and there are 11 rows. Pretty cool. You may pause your video and double check this idea. Absolutely correct. You start with factoring the 40. It's going to be 2 times 2 times 2 times 5. And you factor the 28 prime, factoring 2 times 2 times 7. The GCF of these two numbers is going to be 2 times 2 equals 4. To find the number of rows, you need to divide this 40 into equal groups of 4 designs. So 40 divided by 4 plus 28 divided by 4. 40 divided by 4 is 10, plus 7 is equal to 17. You need to practice very well. Thank you guys. See you soon. Bye.